Hi, my name is Maxim and today I will talk about nuclear reactions, ionization and radioactivity. Nuclear reactions. A nuclear reaction is a process in which two nuclear particles interact to form two or more nuclear particles. A nuclear reactions must cause the transformation of at least one nuclide into ionized. Examples of nuclear reactions are nuclear fusion, reaction of light elements that produce energy in the sun and stars, and an example of a natural reaction is the interaction of cosmic rays with matter. The most notable human control nuclear reaction is the fission reaction that occurs in nuclear reactions. Nuclear reactions are devices that initiate and control a nuclear chain reaction, but they are not only human-made devices. The world's first nuclear reactor went online about 2 billion years ago in Oklo in Gabon, Africa, when a uranium rich mineral deposit was flooded with groundwater that acted as a neutron moderator, and a nuclear chain reaction began. Type of nuclear reactions. Elastic scattering occurs when no energy is transferred between the target nucleus and the incident particle. Inelastic scattering occurs during energy transfer. Capture reactions. As a result of the neutron capture reaction, radioactive nuclides are formed. Transfer reactions. The absorption of a particle accompanied by the emission of one or more particles is called a transfer reaction. Fission reactions. Nuclear fission is nuclear reactions in which the nucleus of an atom breaks up into smaller pieces. Synthesis reactions. They occur when two or more atomic nuclei collide at very high speed and combine to form a new type of atomic nucleus. Peeling reactions occurs when a particle with sufficient energy and momentum enters the core to knock out a few small fragments or break it into many fragments. Nuclear decay occurs when an unstable atom loses energy due to the emission of ionizing radiation. There are many types of radioactive decay, such as alpha radioactivity, beta radioactivity, gamma radioactivity, emission of neutrons. Neutrons emission is a type of radioactive decay of nuclear containing excess neutrons, in which a neutron is simply ejected from the nucleus. Radioactivity. Radioactivity is a process by which atoms decay spontaneously releasing particles and energy. This process occurs because unstable isotopes move to a more stable state. Common units of radioactivity are becquerel, which equals 1 decay per second and Curie, which equals 37 billion decays per second. Every radioactive element or radionuclide has a half-life. Half-life is the time it takes half of radionuclide's atoms to decay into another nuclear form. Half-life range from millions of seconds to billions of years. Ionizing radiation. Ionizing radiation is a form of radiation that has enough energy to knock electrons out of atoms or molecules, creating ions. There are such types of ionizing radiation as alpha particles are made up of 2 protons and 2 neutrons. They are identical to the nuclei of helium atoms. These are very heavy particles, about 7,300 times the mass of an electron. They cannot penetrate a sheet of paper or the layer of dead cells on the surface of our skin. But if they are realized inside the body form, a radioactive atom inside or near a cell. Alpha particles can degrade damage by destroying living cells. Radium and polonium are 2 examples of alpha emitters. Beta particles are energetic electrons emitted from the nucleus. They are born when a neutron decays into a proton. Since neutrons are neutral particle and protons are positive, a negative electron must be emitted to conserve charge. This particle can penetrate the substance more than alpha particles, and a small aluminum plate is required to stop most beta particles. Beta emitting radioisotopes are found in the fission products produced in nuclear reactors and nuclear explosions. Gamma and X-ray are composed of packets of energy known as protons. Protons have no mass or charge and move in straight lines. The visible light seen with or eyes is also made up of protons, but with lower energy. If you visualize the protons of gamma and X-ray radiation, then they will be like weightless bullets moving at the speed of light. That is all I wanted to tell you today. Thank you for your attention. If you have questions, then leave them in the comments. Goodbye.